So we've been able to work things where we have a mean, let's say we have a mean of 60 and a standard deviation of 10. So this, I believe you all okay with drawing this out? Agree? Come on. All right, we've seen that way too many times. Agree? All right, and then we start getting into stuff saying, hey, if we have a certain sample, then we change the standard deviation to the standard error, which is, in this case, it would be 10 over square root of 10. Nope.
Oh, wait, no. It's like 20.
So then, all right, so if we do our normal curve based on this, then this would be 63.16. And this would be 56.84. Hello. Good to see you. Okay, so what's happening with this information is as I just have a mean and a standard deviation, 68% fall within one standard deviation. And then if I do a sample of 10, it basically changes from a 68% probability to a little bit less because we're narrowing our gap a little bit. And as our standard error becomes smaller, so like let's say I had a sample size of 100, then my standard error is equal to 10 over square root of 100, which in this case would be 1. So this gets real close. So 61 and 59. Okay? So what happens is I take more and more of a sample. I try and get closer and closer and closer to what the mean was. Now, if we didn't know what the mean was, if we keep taking a random sample of people over and over and over again, we're going to start getting the mean of those different samples. And if we take enough random samples over and over and over again, we start realizing we're kind of floundering around a certain number. Sometimes we're above something, sometimes we're below it, but you keep going. But if you were to take an infinite amount of samples, random samples, which I realize you can't, but just go with me on this, we would actually get to what the mean would be. Okay? So the mean a lot of times becomes a parameter because we might not know exactly what it is. Well, we're going to start talking about something called a confidence interval. And this is on page 13. Okay, now, here is a hard thing with the confidence interval. It's a way of estimating the population parameter. Remember, the population parameter is what you think the mean is, if you don't know it. That incorporates the margin of error. The goal of the confidence interval is to capture the parameter with high confidence. Okay, so we are amongst an election year. We've already probably started seeing some sort of campaign stuff. Agree? Whether we watch it or we ignore it, it's up to us. But you will start seeing when polls start coming out, and polls start coming out saying candidate A or B or C, whoever your candidates are for whatever thing, it'll say they are leading the polls by 55%, margin of error plus or minus 5. Okay? something like that. But those poles change. So this is a real goofy thing, and I'm gonna say what this is, and then we're gonna unpack it a little bit. So let's say I have a 90% confidence interval. Okay, that means our margin of error is plus or minus 5%. Okay, now let's see if you can pick up what I did. Let's say I had a confidence interval of 80%. Our margin of error, MOE, is plus or minus 10%. Anyone see what the pattern could be?
70%, 60%, 50%.
Yeah, but look at this margin of error, plus or minus 5. If I go plus 5 and I go minus 5, how big is that distance? If I go positive 5 right, negative 5 left, how far is it from negative 5 to positive 5? 10. 10 plus 90 is 100. Okay, look at the 80. If I go 80% confidence interval, margin of error, hello?
So it's all connected to 100.
Yeah, that's exactly right. So the distance on plus or minus 10 is 20. 20 plus the 80 is 100.
What does MOE stand for?
Margin of error. Okay? So let's kind of start unpacking this a little bit. So what this basically means is if I took that 90% confidence interval and I was at plus or minus 5, think about your normal curve being this. Okay? So this has a certain width, but if I said 80% plus or minus 10, this is going to go out a little bit further. And it goes a little bit further, a little bit further, a little bit further. Okay? So let me ask you this. If someone were to say, hey, I'm 99.9% sure, that's a confidence interval. We're almost 100% sure, 99.9% sure. What that basically means with the normal curve is I have to really spread out. I have to really spread out the region of the area under the curve that I'm looking for. Okay? So if I said it was 99, if I was 99.9% sure that if I collected data again, that my data would fall in between, 99.9% sounds like an incredible thing. Okay? Unfortunately, it's an inverse variation based on what our picture should tell us. Okay? So let's walk through, see if we can figure this out. Example 1, they talk about medical researchers are trying to estimate the average cholesterol level of adult women in the United States. As always, they collect a sample of random U.S. women that might produce a 95% confidence interval. Okay? But they might say that if this is their confidence interval, if somebody says, hey, I'm 95% sure we are going to eat pizza tonight, are you pretty sure that when you get home there's pizza sitting there? I mean, 95%. I mean, there's a certain level as far as percentages go that you might not, if someone says, hey, we have like a 10% chance we're having pizza tonight, you're probably thinking there's something else on the dinner table. Okay? But let's say they feel that you have 176 plus or minus 20, which is from 156 to 196, meaning you subtract 20 from 176 and you add 20 to 176. So what that 156 to 196 means is basically would mean in this context. We are 95% sure that if we continue to collect data the way that we are doing it, we're not changing any ways that we're gathering data, we're doing it the same way over and over and over again, whether it's just taking random cholesterol tests throughout the United States over and over and over again using the same database, that we're finding that the cholesterol level, we're 95% sure will fall somewhere between 156 and 196. That doesn't mean 176 is the mean. That just means that's the halfway point between where we're confident. Now, let's say we had done another sample. Let's say we took another sample of 30 people. Let's say they came to 155 cholesterol level. Okay? So 30 is a good enough number for a random sample. Agree? I got 155 for that sample. But I'm 95% confident that plus or minus 20 of some value I think is in between, I go from 156 to 196. So do we accept 155 being it's outside of it? Like I want my data to fall between 156 and 196, 95% of the time. So did we do something wrong if we got a sample and we found that the average was 155, being that's outside of it? And let's say I picked another random sample of 30, and I found this random sample to be 197. Okay? Did we make an error in it? No, that's part of our 5% that we are uncertain about. Okay? So it is possible those things could take place. Okay? Now, the bigger and bigger this plus or minus number would be, the bigger and bigger this is, the more confident I start becoming that I will land within that parameter. All right, so let's investigate a little bit further as we go down. Now it says, this is interpreted that we are 95% confident that the average cholesterol level of all U.S. women is between 156 and 196. The confidence interval above 176 is the confidence interval above 176 is called the point estimate, is our best single estimate of the population parameter. That means we aren't totally sure this is actually where it's at, but we have taken enough random samples that we keep hovering around that number more and more and more. And this, fortunately, is where computers can run through iterations to show that you get close to that. But we're not sure if that's our exact average, but we think it's about there. But we do know that we're with 95% confidence with our data testing that our actual average for cholesterol level of women in the United States taken randomly is going to fall between 156 and 196. Okay? So let's see, it's at that. The margin of error is 20. So we are 95% confident that our point estimate is accurate to be within 20 points. That's your plus or minus 20. Okay? The 156 to 196 is called the confidence interval. It utilizes interval notation from algebra and calculus, suggests with 95% calculus, with 95% confidence, the actual cholesterol level in the U.S. in women is between 156 and 196. And then we'll learn some more procedures for this. Okay? So down at the bottom of page 113, second to the last paragraph says, the researcher sets a confidence level. The researcher wants to create a confidence level which they are almost certain captures the population parameter. They might want to choose a confidence interval of 99% or even higher. Okay, you never get to 100%, but you can get to 99.9, 99.99, 99.99, things like that. As those values go up, the wider and wider and wider a plus or minus value becomes. Okay? So such intervals are very wide, so the precision is lost. Lower confidence levels, such as 90% or even 80, will be more precise, but the probability is higher that the interval will not have captured the population parameter. Okay, so we have to kind of get our mindset that 99.9 versus 80% confident. If I talk about a margin of error here, you're talking about a huge amount of area under the curve that's going to take place. Okay? That way you can say, hey, I'm 99.9% sure something's going to fall within that poorly shaded green region. But if I was 80% sure, this is going to be a lot closer. Okay? Meaning you have something that's taking place outside of your margin of error. Okay? Those are big things to realize. So the example above regarding high cholesterol level of women, the confidence level is 95. The researchers set the level to 99. The margin of error would be increased, and the confidence interval would be much wider, such I have shown on the board. Okay. Example 2. Let's assume that the owner of a major store chain wants to know the percentage of people who enter the store who make a purchase. The owner wants a 90% confidence interval and collects data as needed. The resulting confidence interval was as follows. So 56% of the people that come into the store with plus or minus 5%, so which would be 0.51 to 0.61 or 51% to 61%, actually purchase something. Okay, do people walk into stores all the time and don't buy anything? Yeah, I've seen y'all at King Soopers, at least when you're a freshman, going in there and you're ripping off stuff. Okay. Not me. No, I go to the other store. The point estimate is 0.56, which is 56%. That means our estimate is that 56% of all customers who enter the store buy something. The margin of error is 0.05, which is 5%. So we could say with 95 or 90% confidence, we believe that our estimate is 56% accurate within 5%. So between 51 and 61%, or as decimals. Okay? It's to be noted that confidence intervals can provide powerful statistical evidence. If someone were to argue that half the customers who enter the store were buying something, our interval has solid evidence to counter that. After all, the entire interval is above 50%. Okay, so we're going between 51 and 61%. On the other hand, if someone makes a claim that 60% or more customers bought something, we don't have evidence to counter that because 60% is within the confidence interval. It must be considered plausible. So what they're saying there is our margin of error is 51% to 61%. So if somebody said 60% or more, come on, or more, buy something, being the 60 is in here, that's where the 60 falls. We don't have the evidence to say that. I mean, the 60% is within this parameter, but they're saying 60% or more. 60% or more, we don't have the evidence to support that. Okay, it's because it's within the parameter. Okay, it needs to be noted that the confidence interval can provide powerful statistical evidence. If someone were to argue less than half, okay, we did that. On the other hand, if someone were to make the claim, we did that. So when we evaluate the statistical evidence, it isn't appropriate to draw judgments based upon how close a value might be to the edge of the interval. Someone might try to argue that the interval provides evidence less than 60% of the customers who enter the store buy something because of the interval is below 60%. Logically, that's faulty. However, at the end of the standard interval we choose, every value within the interval must be considered plausible. Okay, every value outside of the interval would be considered very unlikely, but not impossible. So what that means is, if you looked at a normal curve and you wanted something to happen in the shaded region, something can happen here and here as well. Okay? It doesn't mean we did something wrong. It just means that maybe our confidence interval is not broad enough. So if it's not broad enough, we have to change our confidence interval to be lower. We have to go from 90% to 80% or to 70%. Okay? So the lower your confidence interval becomes, the broader the area under the curve that your data would fall into. So if someone were to say, hey, I'm 1% confident something were to take place, okay, you're talking about you're dealing with 99% of the area under the curve, where you have 0.5 and 0.5% on either end of the normal curve. So if someone says, hey, I'm 1% confident this is going to happen, it has a really good shot at happening. If they say it's 99.9% chance it's going to happen, your margin is so far. But if I said, if you gave a 1% confidence interval, you're talking about this. There's your 1%. Okay, that's really unlikely that you're going to you're going to randomly select people and they're going to fall right on that line. But if I get to the 99.9%, I mean, we're talking about almost all the area under the curve. So 99.9%, we have made this so wide that we should be able to capture our information. But if we said we're 1%, we are very narrow. It's going to be really hard to capture that our stuff falls between that. So just think about like the probability of an event happening that takes place. And I know you're dealing with percents compounded with more percents, compounded with more percents. But that, my friends, is how we roll with this stuff. Okay, so give page 81, 82 a shot. Talk to me about it. We'll go over it tomorrow. We'll make sure we know how to do this, okay? Confidence intervals, be very careful because it starts playing in your mind. It starts playing with your mind going, but the more confident I be, it means it should happen. You're right, but I'm so broad that with my numbers, if I said I'm 51% or I'm 99.9% confident that 51 out of every 100 people will fall into this category, plus or minus 40, that's a huge sway of all my area. Okay? So that's what I got for you. You know what to do.